Uh, Good morning, everyone. It's Glenn McKnight from the Virtual School of Internet Governance. Welcome, everyone. We have a great lecture this morning by Dr. Amreech Phokeer. He's an expert well, we'll say in the technical realm within the internet. This is our infrastructure session. What I have is a quick purveyance of his bio. So just bear with me for a second. Okay. You work 100% now with ISOC, right?
Yeah.
Okay. So prior to that, his life was a researcher with Afrenek. For all the students who are taking this course, Afrenek is one of the IRRs, and they just recently had an election. If you look at the discussion thread, people are talking about the new board that they selected. So what we're going to be talking about today is his research, and it was not only what he's done with Afrenek and ISOC, but a recent work that he's done on the security framework of the RPKI and DNSSEC, and that was with Afrenek. So he received his PhD in University of Cape Town in South Africa, followed up with additional. If that wasn't enough, prior to that he did his master's at Telecom Fancy, also in France, also following up with that master's in science in information security at the University of London. He, along with Rukia, are patriots of the beautiful island of Mauritius, and I understand you are a watercolor artist and occasional scuba diver. So that's great repertoire. So back to you, Amreech, welcome.
Thank you, Glenn. Good morning, everyone. Good afternoon and good evening, depending on where you're connecting from. And Glenn, it is an absolute pleasure for me to be here with you all. And thank you so much for the kind invitation. When I first received that email, I was a little bit intrigued. I haven't heard about the Virtual School of Internet Governance, though I have done a few lectures at different school of Internet Governance, namely the one in Africa called VSIG. But I'm completely thrilled to be here with you and to talk about a project that has been funded by the ARIN Community Grant. So as you mentioned, Glenn, ARIN is the RIR, so the Regional Internet Registry for North America, and their role as an RIR is the management of IP addresses, but they are also supporting the community, and in this case through by supporting research through their community program. So let me share my screen quickly. All right. So without further ado, the project which we have been investigating for the last 6 months is called Exploring Potential Use Cases for RPKI Signed Checklists under RFC 9323. So these a lot of jargon here, but I'll try to unpack that for you, and hopefully you can make a bit of sense out of this work, and probably and hopefully you can take home some lessons and also possibly apply it to your different use cases that you have. So let's first get into a bit of background of what is RPKI. If you are in the technical space or in the routing space, there is a technology, or actually a set of standards, which we call RPKI, Resource Public Infrastructure. So I think this ties back to what we are saying with the regional internet registries. So these are bodies. There are 5 of these registries, and their role is actually to manage those IP addresses at a regional level. And on top of them is IANA that is providing those resources to those regional internet registries. And then similar as a tree structure, those regional internet registries will be distributing those IP addresses to their internet service providers and other network operators that are operating within their geographical boundaries. So this is basically, in a nutshell, how the IP allocation hierarchy is, from IANA to the RIOs, and then from the RIOs to those that actually need IP addresses and AS numbers to operate. Now, as you know, the internet is glued together by a protocol called BGP, Border Gateway Protocol. And this protocol is used basically to connect independent networks together. So one will be sharing a route to the other. So there is a learning process that goes on, and one is going to learn a route from another network, and they would also propagate that route that they have learned to other networks. So this is how the Border Gateway Protocol works. It connects network with one another, and this is how we get the internet. This is how autonomous systems, so autonomous networks, can reach other networks on the internet. The issue is, as you know, the internet wasn't built with security in mind. So for a long time, we have used the internet because we thought it is a trustworthy system, because a lot of interconnections happen what we usually call with a handshake. I want to connect to your network. You want to connect to my network. Sure, let's do it. Sometimes it is over a business agreement, or sometimes it is over a peering agreement where there is no where it is settlement free. So there is only exchange of traffic. There is no exchange of funds, basically. So a lot of these interconnection agreements were based on trust. But trust, as you know, nowadays is not enough. And so the routing system is susceptible to different types of hijacks. And we have seen in the past where the banking systems were hijacked. One of the famous anecdote is when YouTube was blocked in one country. I think it was Pakistan back in 2008. But the announcement, the information about the route to reach YouTube was actually propagated to the whole world. So basically, Pakistan was mimicking as if they were YouTube, because they wanted all traffic from within Pakistan to go to them, so that it is blocked eventually. But what happened is that Pakistan Telecom also announced this route to the whole world. So they were basically saying to the whole world that I am YouTube. If you want your traffic to YouTube, please send them to me. So it is an example of a hijack. They are basically hijacked the prefix, so the IP address range of YouTube, and then basically through that means actually without them knowing, so it was not intentional. So a lot of Asia Pacific traffic that was YouTube, instead of it going to YouTube, it was going to Pakistan Telecom. So for an hour or two, there was a big outage. So that's one example. There are many other examples that there have been in the routing ecosystem. There have been in South Korea, there was a case of a blockchain or Ethereum system getting hijacked, and therefore funds were actually redirected to the wrong account. So there can be potential impact of those what we call BGP hijacks. In that case, engineers at the IETF, so IETF is the standardization body of the internet, came together and say, okay, let's try to fix that. And they came up with something called resource public infrastructure. So it is basically a public key infrastructure. So very similar to what you have when you're browsing a website and you see a certificate attached to your browser saying, okay, this domain has been authenticated. So it is the same thing. So RIOs, the ones that are responsible of allocating IP addresses, are also now responsible of allocating certificates to those people and organizations that are holding IP addresses and autonomous system numbers. So therefore, when someone in a country wants to get IP addresses, they can also get a certificate certifying that these IP addresses are you are the legitimate holder, and then you can basically use that to certify your routing. So announcement that you're doing on the internet, you can also certify that, and there is a whole mechanism in place that does the validation, and then the routers can then decide to accept or reject those announcements that they are receiving based on those certificates and based on those information in the RPKI. So RPKI has been on for quite some time now, maybe more than 10 years, and it has been standardized also quite some time ago. And roughly 50% of all IPv4 addresses or prefixes that are seen on the routing table are already covered by route origin authorization, which is a technique to secure those announcements. And therefore, so this is being well adopted, even though if we want more adoption to secure routing and prevent either what we call fat finger errors or BGP hijacks, we need more of the deployment of these stock technology. However, we have seen that there are some loopholes. So as much as the technical aspects of, for example, a router communicating with another router, sending a route, those have been secured to some extent using RPKI. We have seen that there are a lot of, I would say, business components that comes part in the interconnectivity business, if I can say so. Has it been secured at all? It's still very done in a very simplistic way. An example is, I am an operator. I need resources from another bigger operator. So I have an upstream provider. So I'm the small operator. So usually I need to go reach out to those operators saying that, oh, can you issue me a letter of agreement, an LOA? This letter of agreement is basically saying that the big operator is allowed to advertise the prefixes of the smaller operator, because this is how it connects to the internet. So as much as the whole technical thing is secured by RPKI, that relationship of let me sign a paper giving approval for one network to advertise my prefix, it hasn't been secured. So this is where after a lot of deliberation at the ITF, they decided to create something called RPKI sign checklist. Obviously, the idea is actually, can we build a mechanism that can basically be used to authenticate almost anything or everything? Because I talked about a letter of agreement. There can be, if I put some information in the WHOIS database, so WHOIS database and information where operators go there and get information about other networks. If I put some information in the WHOIS database, how do I authenticate them? So possibly if I use an RPKI sign checklist object and use that to sign whatever information I put, it will create an additional layer of security. So this is the whole point around OPKI sign checklist. It is basically just an object that is used to sign almost everything that someone needs to actually authenticate. So what the mechanism is that as a network operator, I will receive a certificate from my regional internet registry, and I will use those certificates to create those OPKI sign checklist objects, which can be used to sign, as I mentioned, anything that I might be needing, or also anything that other people might be needing to verify that I have created. So the whole point of this study was to understand what are the potential use cases of those RPKI sign certificates objects, and what are the current challenges of using RSEs and deploying software support for RSEs. This RSE standard has been there for maybe 2 or 3 years, but we haven't seen much uptake on this. So we were wondering, and this was the main motivation of this research, is that why is there no motivation for the adoption and deployment of this technology? So how it works, I tried to explain that early on, but I will just do that again quickly. So what happens is that you are the resource holder. So you have received IP and OS numbers from your regional internet registries, and you have a document that you want to certify. So what you will do is that, of course, you are not going to certify the whole of the document. You can create a hash of the document. And then using your own certificate. So the fact that you're a holder of that certificate, it means that you have a private key. So when you have a private key, you are able to sign a certificate, right? Assign an object. So you will sign this hash and bundle it together into what we call an RSC object. Now, your relying party, so let's say your upstream provider, needs now to verify that information. So they will receive the RSC. First of all, they will check whether it is valid. So as any certificate, there are a few checks that you can run to see whether it is valid. For example, is it expired? Is it validating with regards to the chain of trust? As a PKI, you have to follow the chain of trust up to the root to see whether there is validation. So if it fails, it fails. But if it's valid, then you go and check the hash within the document. So you will also receive the hash itself, or the document that you can hash yourself, and then check whether the hash matches. If the hash matches, then pass. There's validation. If not, it fails. But if it passes, then it means there is validation, and therefore you can continue. So let's look at the potential use cases. So on the internet now, you are seeing a few of those use cases that are coming up. The first one is bring your own IP. So this is especially relevant for cloud operators. Nowadays, you have many cloud operators, and either you buy a service with them, and then they would provide you their own IP addresses. Then, in that case, nothing to do. But if you are a big network, but that wants to bring their own IP, but then use the infrastructure of the cloud, in that case, you would bring your own IP addresses that you receive from your favorite internet registry. In that case, how do you certify that? How do you certify that those IP addresses belong to you? You would use OPKI, saying that those addresses belong to you. But if and using the RSC, you can create a special object, say that, okay, those addresses really belongs to me. There is also the case of the Internet Transit Service, which I mentioned before. So a big operator dealing with a smaller operator. The smaller operator usually establishes a relationship using what we call a letter of agreement. Oh, sorry, a letter of authorization. So the Internet Transit Service will require the small operator to provide this letter. And this letter, if it's certified, it will provide better security. Number 3 is routing information databases. So I talk about WHOIS, where you can put information about your own network, but you can also put information about your routes. How do you want to transfer routes from your network to the other networks? And how are you also receiving routes from other networks to your network? So there is a protocol called RPSL, Routing Protocol Specification Language. And but this information in the WHOIS database is not authenticated. So a use case is to actually use this RSA object to certify those entries in the database. And then finally, geolocation. There is also a newish protocol called GeoFeed, where you actually can report on your geolocation. So as you know, geolocation is important because usually, for example, CDNs want to reach the closest networks, and having accurate geolocation information is important. So if you're adding information about your coordinates, why not also secure that by signing that information? So making sure it's authenticated. So starting with the bring your own IP, as I mentioned, the customers could bring their own resources, prefixes, and send to cloud providers. And before onboarding those resources, the customer needs to prove ownership. And how do you do that? Using the OPKI sign object. So these are the current practices that are being used for bring your own IP. They are using WHOIS-based method. So again, WHOIS is the database that anybody can basically put any information in there, but it lacks security. There is the LOA, letter of authorization. So usually it is a letterhead, a letter with a letterhead, and then some blurb saying that I authorize you to advertise my prefix. There is the OPKI ROA, which is like up to now the most secure way to do that. But it is ROA is used for basically for routers to actually do the authentication. It doesn't allow, let's say, a business person to do an authentication using ROAs. And finally, RDNS.
Amreech, can I interrupt you for a second? There's been some dialogue in the chat, and I wanted to make sure that in case some of the questions or comments actually illuminate some of the things you're saying. So I'm going to call out Bill and Moyable. Is there anything you guys want to point out to Amreech as a question or point of clarification?
I'll take a shot at it.
Okay, go ahead, Bill.
If I may. One of the challenges on the horizon, not today, but visible on the horizon, is the rise of quantum computers, which currently are not a problem, but fairly obviously down the road the technology will evolve to the point where they are, because these allow breaking the cryptography methods, including the ones you're speaking of, in a matter of hours rather than centuries. The security of all these things is based on the fact that it's not that they can't be broken, it's just that they take several lifetimes to, or maybe several centuries to break. And when that delay gets small, the the security disappears. As I say, it's not something that's a problem now for things like this. It has the potential to be a problem down the road. Fortunately, there are some alternate mathematical approaches which can't be broken that way, but they're not to the point where they're where the technology is on the market yet. I know a couple of people who are working on them, but they're not there yet. Anyway, that was all I wanted to bring up. Thank you.
Thank you, Bill. Moyable, you're going to add something to that, or are you responding to something else?
Yeah, actually, there was some question or confusion, like whether the incident in Pakistan was a hacking issue or not. So I just share my understanding on that. So if we would like to understand what happened in Pakistan, I think just need to quickly understand how the things work in the
Sure.
operators when they would like to pass traffic from one operator to another. So they announce like prefix so that so they actually pull traffic from outside. So in case of Pakistan, what happens is that like they actually made some mistake as per my understanding, and so that's why they were pulling traffic for Facebook to their network. So as if like other networks could reach out to the Facebook through their network. So that's why like as their network was not like big enough, so there was a choke point, and like so everything was like disrupted.
I
So
can explain.
that
I can explain. Yeah.
yeah, you could.
Yeah.
So I would like to add one more thing. So that was previously the agreement was like just operators used to trust each other, like whatever they announce, other operator used to receive. But I think after RTKI, what will happen that they will not only blindly trust, they will actually validate it based on the like the way we access the websites, like the secure websites. So when we access the website, we see a log button right on our browser that it's a valid website. So that way it will be validated that whenever someone would like to pull traffic, so other operator will can validate that whether actually that is the correct path. So yeah, so just I would like to add that point. Yeah, thanks.
Thank you, Mohibul. Yeah. So maybe quickly let me answer to Bill. So Bill, you made a very valid observation about quantum cryptography and also post-quantum issues and how these algorithms that are being used, especially here, are solid and robust against post-quantum crypto. So the RPKI is the same as any other technology that we're using, whether it is DNSSEC, whether it is using IPsec for VPN tunneling, and other PKI, so public key technologies. It's all the same. Again, it's based on as you pointed out, on the algorithms that are used. Some of them are less susceptible to be broken by post-quantum cryptography. So right now, at the moment, there has not been any recommendations to change those algorithms. So we are still using those that are quite robust. So for example, using SHA-256, etc. But we basically, operators and designers of the software, will take into account what, for example, NIST is providing as security guidelines. So the NIST has some very detailed guidelines on the RPKI system and what sort of cryptography we should be using at the moment. So definitely, we would see maybe changes in the algorithm that we have to use or to adopt as we progress and we see clarity in the post-quantum world. Great. So yeah, I wanted quickly to touch upon what happened in Pakistan. So I'll try to see if I can do a quick design here. Yes. Yeah, cool. So let's imagine this is Pakistan Telecom. So Pakistan Telecom itself is receiving transit from big operators. I think back in those days, or might still be the case, is PCCW, right? And Pakistan Telecom itself is providing internet access to ISPs in Pakistan, right? ISP1, ISP2, ISP3, etc. And then you have YouTube, which is a global network, and everyone has access to YouTube, everything. So for some reason, namely political reasons, YouTube was so probably the regulator in the country ordered operators to switch off YouTube or to prevent users to have access to YouTube. So what happened is that for Pakistan Telecom say, okay, how do I do that? One way to do that is, okay, I'm going to advertise the prefix of YouTube Telecom. So they send an announcement to those ISPs saying, okay, if you want access to YouTube, send this traffic to me. So they advertise a prefix, I don't know, a prefix and a prefix length. So they advertise this prefix to the operators. So what happens is that, great, those operators, instead of going to YouTube, they are now redirecting the traffic to Pakistan Telecom. And basically, the Pakistan Telecom achieve its goal of redirecting traffic and then blocking the traffic. But the issue is that this announcement should not go out in the world. But there was no filters placed here. So this announcement here was pushed to PCCW, which is the upstream provider. The fact that it has done that, so PCCW, of course, is connected to the whole world because it is what we call a tier one provider. Tier one provider is one of those big networks that have access to the whole world. So they can basically reach anywhere in the world. And PCCW also, when they received that fake announcement from Pakistan Telecom claiming that it is YouTube, they did not filter that out, and therefore propagated that to the whole world. And this is why all traffic from anywhere, it was mostly in Asia Pacific, instead of it going to YouTube, was going to Pakistan Telecom. And this happened for like an hour or 2 hours. And obviously, they have seen that and they have tried to apply mitigating techniques. Like, for example, YouTube, for example, tried to advertise what they call more specific prefix. So when there's more specific, traffic tends to go to the shortest path or to the more specific. So in that case, they could try to mitigate that, but it really reverted back to where it was when Pakistan Telecom withdrew this rogue announcement here, and then things could go back to normal. So that happened because there were no mechanism for PCCW to drop that announcement, that rogue announcement. There were no mechanism in place. But with OPKI, what will happen is that PCCW will put what we call a validator here, close to its network, saying that when they are accepting announcement, they should drop invalid prefixes, invalid announcement. That whole validation tool here is going to first check whether there is a route origin object, route origin authorization object of this prefix, and then cryptographically verifies it. And then if that information is not there, it will drop it. If it's there, it will allow it. So you can basically tune your filter to say whether I accept. But if it's unknown, what do? I still accept it. But if it's invalid, I should definitely drop it. And this is what most of the networks are doing. So they have a validator that is used to connect to their router, and their router is now able to drop invalid prefixes and therefore protect themselves from what we call rogue announcement. I hope that was clear.
Anybody have any comment on that for Amreech? I don't see anything in the chat. Okay, I guess it's clear as mud for them. Okay, thank you. Proceed.
Thank you. Okay, we also did like a quick survey of the different cloud providers. So we have Google, Amazon, Oracle, OVH, and Vultr, and what are the different techniques that they are using. As you can see, it's quite varied. There is no standardized way for cloud operators to actually do that authentication and make sure in the case of bring your own IP, there is an authenticated way to validate that information, except in the case of ROA. So ROA is a product of RPKI. So to some extent, using ROA is the most secure way, of course. So challenges of the current practices, I mentioned, so the WHOIS is subject to email security. So not everyone is using secure email. So this is also a point of vulnerability. We looked at both the security and the privacy aspect and the ease of use aspect. And definitely WHOIS is the most secure, is the least secure system that you can use. ROA and LOA to some extent, but LOA, as I mentioned, it is only a letter between a provider and a customer, so that LOA can be faked as well. So what we are saying, that we are advocating that in the future, those that are doing bring your own IP, so the cloud operators should be using RSC to validate the information that a customer is providing. So we explain how you can do that. So you can, for example, use a random string that you will transmit to your cloud provider, and the cloud provider will receive the RSC object with the hash. And then and then validates the hash and compare the random string and see if it's matches. So this is the example of the internet transit service. So as I mentioned, upstream providers, when they need to announce the prefixes of their customers, they need to enter an agreement, which is the letter of authorization. And this is a perfect use case for a letter to use the RSC. Another example is routing databases. Mentioned about WHOIS, but there are many others. For example, Internet Exchange Point, many of them use a database called PeeringDB. So PeeringDB is only based on the simple login authentication system, but the information in there can be manipulated, can be changed, can be edited. So but if there is a certificate that can be used to sign some information, it makes the whole chain a more secure, chain of information more secure. And finally, I talked about geolocation. If you can, if one operator is reporting on their geolocation, you can also sign this information so that any relying party out on the internet can verify that information and trust what you have actually said is true. So how can RSE be used? It can be used for ownership verification method. Okay, but it might not be suitable for continuous verification and revocation. Continuous verification means the verifier can continuously validate the RSE during the service period. Revocation, resource owners can. So there are two things here. There's the verification where, as a relying party, I'm receiving this RSE. I can do the validation, right? But the revocation of it is only done by the owner of the resources. So there need to be some coordination that happens. So to conclude, RPKI RSE can be widely used for cloud services, internet transit services, and a variety of third-party databases. All of this at the moment is in a pretty blurry, untrustworthy situation where they are using different types of techniques and tools to share information, and there are many security loopholes. And RSE can really help to secure everything. And so what we have seen is that also current RSE, the standard is fully functional, but we have seen right now there aren't many implementation options. So there is only one or two tools that are available, and there are still very much of a proof of concept. So the fact there's no tooling available is some sort of deterrent for adopters and early adopters to try it out and try to be more secure in their communication and trust building exercises. So we have, as part of this research, we have done a survey where we reach out to operators and they gave us their feedback. And the top barriers that we have seen is that, first of all, there is a lack of awareness. Most of them were not really aware of this technology and do not know, for example, where to look for information, if they need training, etc. And some of them think that integration with the existing API infrastructure might be complex, because right now, even running the API infrastructure is quite complex. So adding a layer on top of that is an added layer of complexity. So there is that apprehension. 30% think that we have been doing LOAs and signing letters by hand and shaking hands for many, many years. What is the business benefit of using OPKI RSE? And finally, regulatory and legal concerns. Obviously, lawyers, when they get into the picture, is this again add another layer of complexity with regards to liability and compliance. I think I will stop here because I will just be repeating myself. But I hope you got the gist of this project, and hopefully in the future when they are going to talk about OPKI and OPKI sign checklists, you will be at least a little bit aware of this existing technology and how it can be used to make the internet better in some sense. So thank you very much for your kind attention.
Great, thank you so much. I see that Moyable interceded on the chat, so I want to call him up because he talked, you left out in your chart the Microsoft Azure. So go ahead, Moyable.
No, just wondering, like, so bring your own IP. You've shown a list, so I haven't seen the Azure. So I was just wondering, like, is it like any issues with Azure that it is not supporting bring your own IP?
maybe at the time when we were doing this study, we didn't reach out to Azure, or maybe they were not doing it yet. I'm not sure. So we did that study maybe 8 to 9 months ago. So not sure. I need to go check again.
But yeah, I shared the public documentation of their bring your own IP,
Okay.
so just for your reference. Yeah.
Yeah. Thank you.
Okay. Anyone else have any questions? Rukia, Bill, Twakar?
No,
Oh,
all clear.
yeah, go ahead.
Nothing here.
Okay. It looks like it's absolutely, you did such a great job there. Speechless, Amreech. So where does this research go from here? So you did a survey, and some of the stats were not comforting in terms of awareness or action. So where do these organizations go? Where do they get the appropriate training? Where do they get the skill sets? Is schools teaching this, or in-house development happening? Like if it looks to me, I know it's not an extensive study, but regardless, there's some troubling numbers there.
Good point, Glenn. Yeah, I think right now we are still in the discovery phase of this technology, and the mere fact that there aren't many implementations of tools that, for example, can create those RSEs and can do the validation is not helping for wide scale awareness and adoption of that, definitely. So I think there is some potential for people to maybe to invest into some verification tool that can then be used for training purposes. So that could be, for example, a great idea for a hackathon at the ITF to build to quickly build those a verification tool, which I think is not very complicated because Arin has that. No, not Arin, sorry. Epinic has built a verification tool and can easily put that as an open source that can be forked and then maybe eventually implemented in some other on some other platforms. So there is that phase, and then there is a phase of, okay, maybe embed this whole aspect of RPKI sign checklist in the training, in the BGP training, where they talk about RPKI and route origin authorization, validation, etc. Also include that in their training courses because it is already standard. It is not something that is being or they are trying to standardize. It is already standard. So why not try to put that as a component in the module?
Good point. For the benefit of those that are IETF Montreal is early first week in November. If you can't physically be there, you can always be virtual. And I gave you a link, everyone, that you can apply for waiving the fees. So please do attend. Are you going to the IETF, Amreech?
No, I'm not planning to go to the ITF this year, at least. Perhaps next year, okay, if the chance arises.
Okay, I think Moyable circling back on this theme. Go ahead, Moyable.
Yeah, just to add one thing regarding the RPKI training, just one resource I just would like to share. Like during my last ITF, sorry, ICANN meeting, actually they had a session on RPKI. Actually, that was mostly related to the implementation with DNS. But I think if anyone would like to see it on a practical basis, I think they could see this session. Yeah, so there was some practical demonstration there. I shared the link on the chat. Yeah, so just to add, yeah. Thanks.
So sorry, Moyable, was that the session you mentioned in the chat a few minutes ago? I just added it to the chat again. That was not the last. It was one of the previous ICANN meetings, correct?
I think 82, I guess I mentioned it, like the ICANN 82 meeting.
Okay,
I
ICANN
found
82.
it,
It's
yeah, I think, yeah, I
okay.
think, yeah.
ICANN 85 is this month. Okay. Is there anything in upcoming ICANN meeting that that you want to mention?
Yeah, I haven't seen, but I think they could look into these sessions, Octo sessions. They usually
Yeah, okay.
they usually have this hands-on session. So that was interesting, like hands-on session. So they will teach how to configure RPKI, things like that practically. So there was actually, I think I shared the link of one of the three sessions. So there was three sessions actually.
Okay.
So two other sessions with that. So this was just interesting, like if anyone interested. So I just would like to share the practically how RPKI works, so to understand that.
Excellent. And
Yeah.
as a follow-up on the training, excellent suggestion by Amreech. There's ISOC Learn courses one can go into. I'll put the link into the discussion thread today. So look into that as well. Is there any particular course that you can think of, Amreech, that people should be looking at?
So there are a lot of courses around around routing and also around DNS.
Okay.
But in that case, try to look for if you're not familiar with routing, so start with the routing class, and then you
Okay.
can go into routing security as well. So I've also put the RIPE training webpage. So usually RPKI training is mostly offered by RIOs because this is one of their core businesses. They want their members to be RPKI aware and savvy about this technology. So they do quite a number of courses. So ARIN would do the same. LACNIC, AFRENIC, and APNIC are doing the same.
Excellent. Excellent. Yeah. Okay, folks, it's true. If you guys can't attend AFRENIC or APNIC or RIPE or LACNIC or RIPE session, they do it 3 times a year, but the sessions are streamed and there's no cost to participate. And usually they're only 2 days long. So there's usually an update on their community grants. So you can get a relatively short synopsis of what the research is, but also if you see an opportunity for a topic that has not been touched before, there's a pretty open process for application, and it's not limited in the case of ARIN to only a North American application, because one of our speakers coming up in the next little while, Loris Taylor, will be talking about their project from Oxford under the economic section. So they also got funded through from ARIN. So this is the continuing us pooling the resources that ARIN has done for research. So that looks good. Also, we won't see it for a while, but the major research by ICANN on their grant program, which was a result of the people paying towards the GTLD program, they issued the first battery of research grants, and some of them are very large grants, $500,000 and whatnot, but we won't see the results of those research for a while. But keep your eyes peeled on the ICANN site. Any final comments, Amreech?
So yeah, I would I remember back in the days when RPKI was introduced, it seems to be quite a complex topic and required a lot of training and also discussions, but also hands-on. So obviously reading and watching maybe webinars and tutorials is great, but I would urge our participants here to, if they can, try it out on actual routers or virtual routers, of course, because those training courses usually come with labs. So please don't hesitate and try to get your hands dirty with trying out things, breaking out things in the lab.
Okay, excellent. Well, this has been quite informative. As I said at the beginning, this is not my forte, the technology, but I think I have a greater grasp of the relevance and importance of the work. Thank you for doing this research. Thank you for your time today. Thanks everybody for joining us, and this recording will be available in the next hour, and I'll send you a link as well. Folks, don't forget to fill out the survey as well. That's it from me, everyone. See you next week in our next session. And thanks again, everybody. That concludes the call today. Thanks again. Bye-bye.
Thank you, everyone. Bye.